The human brain is one of the most complex and powerful systems known to exist. It allows us to read symbols on a page, interpret sounds as language, remember events from decades ago, imagine futures that do not yet exist, and cooperate with others in highly sophisticated ways. Yet despite living with our brains every moment of our lives, most of us understand very little about how they actually work. In Brain Rules, developmental molecular biologist John Medina introduces 12 core principles, called Brain Rules, that describe what modern neuroscience tells us about how the brain evolved, how it learns, and how it performs best. These rules are not self-help tricks or quick fixes. They are evidence-based insights drawn from peer-reviewed research, carefully replicated and tested over time. Medina's central argument is simple but profound. Our brains were not designed for the environments we have built. They were not designed for sitting still for hours, for chronic stress, for sleep deprivation, or for passive learning. Instead, the human brain evolved to survive in dynamic, physically demanding, emotionally rich, and socially complex environments. When modern life clashes with this biological design, learning and performance suffer. Understanding how the brain works does not guarantee success, but ignoring how it works almost guarantees failure. To understand learning, memory, attention, creativity, and intelligence, we must first understand the evolutionary story of the brain itself. Brain Rule 1. The human brain evolved to. The first brain rule is that the human brain evolved to solve problems related to survival in unstable environments, while the body was in constant motion. Every feature of the brain reflects this history. For millions of years, our ancestors lived outdoors, facing unpredictable threats, changing climates, and scarce resources. Survival required problem-solving, flexibility, cooperation, and learning from mistakes. The brain became specialized not for comfort or efficiency, but for adaptation. Inside every human head are 3 evolutionary layers of brain tissue. The oldest is the brain stem, sometimes called the lizard brain. It regulates basic life functions such as breathing, heart rate, and sleep. Sitting above it is the mammalian brain, which governs emotion, memory, and survival behaviors like fear, pleasure, and aggression. On top of both lies the cortex, the newest and most complex structure, responsible for reasoning, language, planning, and imagination. The most advanced part of the cortex is the prefrontal cortex. This region supports executive functions, decision-making, impulse control, attention, and long-term planning. Damage to this area disrupts social behavior, emotional regulation, and reasoning, demonstrating how essential it is to human intelligence. One uniquely human ability emerged from this structure: symbolic reasoning. Humans can let one thing stand for another. A stick can become a sword. Marks on a page become language. Numbers represent abstract quantities. This capacity allowed humans to create culture, mathematics, art, and technology. Equally important was our ability to cooperate. Humans developed the capacity to infer the thoughts and intentions of others, a skill known as theory of mind. This allowed groups to coordinate, plan, teach, and learn together. Intelligence did not evolve in isolation, it evolved socially. The human brain did not adapt to stability, it adapted to change itself. This flexibility remains central to how we learn today. Brain Rule 2. The second brain rule is that physical movement is essential for optimal brain function. Our brains were built while our bodies were moving, often walking as much as 10 to 12 miles per day. Modern neuroscience shows that regular exercise improves nearly every aspect of cognition. People who exercise perform better on tests of memory, attention, reasoning, and problem-solving. Exercise improves learning speed and mental flexibility, particularly as we age. One of the strongest predictors of successful cognitive aging is not genetics or education, but physical activity. Individuals who remain active are far more likely to maintain sharp mental function into their 80s and 90s. Those who are sedentary are more likely to experience cognitive decline, dementia, and depression. Exercise benefits the brain by increasing blood flow, delivering oxygen and glucose, and stimulating the growth of new blood vessels. It also boosts levels of brain-derived neurotrophic factor, or BDNF, a protein that supports neuron health, connectivity, and learning. Even modest exercise produces benefits. Walking several times a week can significantly reduce the risk of dementia and Alzheimer's disease. Exercise also reduces stress, improves mood, and enhances emotional regulation. The brain does not treat movement as optional. It treats it as essential. When we remove physical activity from daily life, we impair the very system responsible for learning and thinking. Brain Rule 3: Sleep well, think well. Sleep is not rest for the brain. It is active, intense neurological work. During sleep, the brain processes information, consolidates memories, regulates emotions, and prepares for future learning. Sleep deprivation severely impairs attention, decision-making, creativity, and emotional stability. Even modest sleep loss reduces learning capacity and increases errors. Chronic sleep deprivation is associated with long-term cognitive decline and mental health problems. The brain cycles through multiple stages of sleep, each with a specific function. During these cycles, memories are stabilized, emotional experiences are processed, and irrelevant information is discarded. Sleep is when the brain decides what to keep. Short naps can dramatically improve performance. Research shows that even a 26-minute nap can improve cognitive performance by more than 30%. This is not laziness, it is biology. Individual sleep needs vary. Some people are biologically wired to function better early in the morning, while others perform best later in the day. Fixed schedules often ignore these differences, particularly in schools. Sleep is not a luxury. It is a biological requirement for learning, memory, and mental health. Brain Rule 4: Stressed brains don't learn the same way. Stress has a powerful effect on the brain. Short-term stress can increase alertness and focus. Chronic stress, however, damages learning and memory. Prolonged exposure to stress hormones disrupts the hippocampus, a region critical for memory formation. It impairs attention, reduces cognitive flexibility, and weakens emotional control. Chronic stress also suppresses the immune system and increases the risk of mental illness. The brain learns best in environments that balance challenge with safety. Predictability, social support, and emotional security reduce toxic stress and improve performance. Stress experienced at home affects performance at school and work. The brain does not compartmentalize stress. Emotional environments matter deeply. Reducing chronic stress is not about comfort. It is about protecting the brain's ability to learn. Brain Rule 5: Every brain is wired differently. No two brains are wired the same. While humans share a common biological structure, individual experiences shape neural connections in unique ways. Brain development is influenced by genetics, environment, culture, and personal history. This wiring process occurs most intensely during early childhood and adolescence, but it continues throughout life. Experience strengthens some neural pathways while weakening others. Learning physically reshapes the brain. This means that people will differ in strengths, preferences, and learning strategies. There is no single best way to learn that works for everyone. Education systems designed for uniformity conflict with biological diversity. Understanding individual differences is not about labeling. It is about recognizing that variability is a feature of human intelligence, not a flaw. Brain Rule 6. We don't pay attention to boring things. Attention is limited, selective, and emotionally driven. The brain evolved to prioritize information relevant to survival, threats, novelty, patterns, and emotional meaning. Multitasking is a myth. The brain cannot attend to multiple complex tasks simultaneously. Instead, it rapidly switches focus, reducing accuracy and increasing errors. Sustained attention peaks at about 10 minutes. After that, engagement declines unless attention is deliberately reset through emotion, relevance, or novelty. Stories, humor, surprise, and meaning capture attention because they activate emotional systems tied to memory and learning. Attention follows meaning. Without emotional relevance, information is ignored. Brain Rule 7. Repeat to remember. Memory is not a recording device. It is a reconstructive process. Each time a memory is recalled, it is altered. Information is quickly forgotten unless it is meaningfully encoded and revisited. Repetition strengthens memory, but timing matters. Spaced repetition is far more effective than cramming. Retrieval strengthens memory more than passive review. Actively recalling information builds stronger neural connections than rereading. Memory improves when new information is connected to existing knowledge and emotional meaning. Learning is not about exposure. It is about reinforcement over time. Brain Rule 8. Stimulate more of the senses. The brain is multisensory by design. It processes information more effectively when multiple senses are engaged simultaneously. Combining visual, auditory, and tactile input strengthens learning and memory. Multisensory experiences create richer neural representations. The brain evolved in environments filled with sights, sounds, textures, and smells. Learning environments that engage only one sense are biologically impoverished. Stimulating multiple senses improves comprehension, recall, and engagement. Brain Rule 9. Vision trumps all other senses. Vision is the brain's dominant sense. A large portion of the cortex is devoted to visual processing. The brain does not passively receive visual information. It actively interprets, fills gaps, and makes predictions based on prior experience. Poorly designed visuals overload cognition. Text-heavy slides and cluttered presentations reduce learning. Effective visual communication relies on clarity, simplicity, and alignment with how the brain processes images. We remember what we see far more easily than what we hear. Brain Rule 10. Music can boost cognition. Music activates multiple brain systems, including those involved in emotion, memory, and language. Exposure to music enhances emotional sensitivity and can support learning and rehabilitation. Music therapy has measurable neurological effects. Music does not improve all tasks equally, but when used appropriately, it can enhance mood, motivation, and cognitive engagement. Music's power lies in its ability to integrate emotion and cognition. Brain Rule 11. Male and female brains are different. Male and female brains show average biological differences influenced by hormones and development. These differences affect stress responses, memory strategies, and emotional processing. Men tend to focus on gist under stress, while women tend to recall details. However, individual variation is large. Understanding these differences can improve communication and collaboration without reinforcing stereotypes. Biology influences behavior, but it does not determine destiny. Brain Rule 12. We are powerful and natural explorers. Humans are born with an intense drive to explore, test, and experiment. Infants behave like scientists, forming hypotheses and learning from feedback. Curiosity drives learning. Exploration strengthens problem-solving skills and adaptability. Educational systems often suppress exploration by emphasizing passive instruction and error avoidance. The brain learns best when allowed to explore, fail, and try again. In conclusion, the human brain evolved for movement, emotion, social connection, exploration, and adaptability. Modern life often violates these conditions. By aligning education, work, and daily habits with how the brain naturally functions, we can improve learning, creativity, health, and well-being. Understanding the brain does not give us easy answers, but it gives us better questions, and better questions change everything.